Can you MIG and TIG weld without a shielding gas? Yes. Almost as long as you could run a vehicle without oil in the engine. I actually did get this question in one of my videos, but I can't find it to respond to. So anybody who's interested, let me tell you what happens when you try to weld a shielding gas process without the shielding gas covering the weld. MIG would last a lot longer than TIG would in the sense that you've got a lot more time to destroy before total meltdown, but the results still go downhill pretty fast. You've got a continuously fed wire into your weld with a MIG, so the process can keep running mechanically even when the welds turn to garbage. Next bead is welded with no shielding gas. You can't even see my original beads because the gasless one was throwing so much smoke that it covered everything up. You can already tell the porosity in the one that was unshielded. These beads hug each other a little bit more, toes wetted into the sides a little bit more. These are just thrown onto the surface. See the porosity in all of it. In contrast, TIG uses a fixed electrode that must stay pristine. Once the tungsten oxidizes, the arc destabilizes and quits working for you. That's why TIG would pretty much stop doing any work for you whatsoever in seconds after the tungsten burns away, while the MIG would keep trying for as long as it's not overheating. Without shielding gas, the arc becomes loud, sputtery, and orange with either process. Oxygen and nitrogen from the air come flooding in, forming oxides and nitrides. The weld spatter increases dramatically, and the puddle becomes porous and bubbly, and the weld itself becomes brittle, full of pinholes, rough and bubbly. So yeah, while the arc will keep going, in effect, you're kind of trying to plasma cut with your welder. Your MIG torch is far less delicate than your TIG torch in that there's no ceramic cup to destroy as it overheats, glaze and crack, no tungsten to destroy, and less of a thermal load here than there are on all the tiny copper components inside here. So mechanically, it'll survive much longer, but you might burn the contact tip from spatter buildup or arc blowback, but you're not gonna melt the gun in a minute like you will with the TIG torch. Especially with shielding gas with a lot of the machines, these are water cooled, like the bigger ones are water cooled. Mine's air cooled, and it's cooled by the shielding gas coming through it. So not only are you losing the shielding gas at the site of the weld, you're also losing that cooling action as it comes along your lead. This is TIG welding, like usual, with a shielding gas. Decent shiny little beads, wet in at the toes. I'm now going to TIG weld without a shielding gas, and I'm going to use the tiniest tungsten that I have at my disposal because this will be sacrificial when you see what happens to it at super high heats without a shielding gas. Once again, I turned off my shielding gas, but it might take a moment to purge from the line. I think you'll see the moment that it happens. And that's all I want to do. That's as much damage as I want to cause to my welding machine. See the ceramic cup that's glowing? And check out the hole it left. Almost welding all right. I did what I could for as long as I could, but it just got too hot, too crazy. Here you can better understand how plasma cutting was invented in the process of trying to invent TIG welding. Wow. The tungsten catastrophically oxidizes. Hot tungsten loves oxygen at high temperatures. With no shielding, gas is exposed directly to the air, and within seconds it forms tungsten oxides that sublime, turn from a solid to a gas. You'll see that tip glow white, hiss, and then just erode away. The tungsten might even spit particles of itself into your weld puddle and turn into inclusions. They'll show up bright white little specks on an x-ray. Those inclusions make the weld weaker, they build up stress spots in weird places, and it also makes the arc harder to start if you were to try to weld over top of that again. Molten puddle goes wild. Without argon, the molten puddle is being blasted by superheated plasma and air. The oxygen and nitrogen in the environment dissolve into the weld, causing oxides and nitrides. These compounds are brittle ceramics, not metals. So the puddle solidifies full of micro cracks, pores, and a slag-like crusties. Crumbs. Hydrogen from air moisture can also be pulled in and dissolved into the puddle, causing porosity and delayed cracking. It's not just ugly, it's metallurgically wrecked. The arc also becomes unstable and erratic because argon's job isn't just shielding gas, it's also an arc stabilizer. It's heavy and inert, forming a consistent column. Without it, the arc flares in the open air, kind of constantly seeking a new path, kind of like a lightning bolt. You'll see the arc wander and flare, sputter, or even like go out entirely. And the current density fluctuates, so you're actually harming your machine as it's trying to figure out what the heck is going on at the work end. The arc control circuit may start surging as it tries to maintain balance. That's where you can get internal damage to the collet body and, like, in the guts, the thinky part of your machine, the power source. No gas means that ceramic cut can overheat and crack and glaze over, and heat creeps up the tungsten holder, annealing and softening the copper collet, which can weld itself to the tungsten or seize right in place. Copper parts, tungsten melts at a super high temperature. These do not melt at a super high temperature, and this is loose. I need to tighten it. Finger tight. O-rings inside of the torch can melt, again, especially in air-cooled torches. So in both cases, it still works for a few seconds. It still runs, it still makes noise, it still makes heat, but you're burning through metal and you're turning precision pieces into scrap. It's one of those you can do it once, but only once situations. The invisible hero of a weld, shielding gas. Like oil in your engine is the unseen difference between everything running smoothly and catastrophic.